This tutorial shows you how to get started with GRASS GIS while doing projections and transformations of GIS layers. GIS stands for Geographic Information Systems. For more background on GIS, and on GRASS GIS in particular, see the link to my other video in the show notes below. This tutorial assumes you are using Ubuntu Linux version 20.04 as your operating system. If you do not have Linux, you can emulate it on your Windows or Mac computer for free. See the show notes for details. In fact, I am emulating Linux right now on my Mac computer using VirtualBox. I have a VirtualBox virtual machine pre-configured with the software I will show you today, as well as other population genetics and ecological niche modeling software. See the show notes below for step-by-step instructions to download and hook up this virtual machine within your Windows or Mac computer. This tutorial assumes you have GRASS GIS installed. Installation instructions are pretty simple and can be found in the show notes. The first thing you need to do is open up a web browser. I have it pinned here to the side, or you can find it by clicking here and searching. Visit my website, joshbanta.com. When you visit my website, it will look differently as I am currently in the process of updating it. So you may see this old version, more likely it will look different, but the content will be the same. Click on Tutorials. Next, click Control F to bring up the search window. Type GRASS GIS into the search. Then click the link under Projections and GPS Data Import that says Files Needed for Tutorial. Click the Download button to download the files to your computer. You may now close Google Chrome. We will unzip the files that we just downloaded and put them in a folder called GRASS Data. Open up File Explorer, which I have pinned to the left, or which you can find by searching down below. With your home directory highlighted, come to the drop-down menu and select New Folder. The new folder name will be GRASS Data. Click Create. Double-click on this folder to open it. If you're on a Windows machine with a Windows mouse, right-click on File Explorer and click on New Window. If you're on a Mac, push down on the trackpad with 2 fingers and click on New Window. Click on your home directory and navigate to your Downloads folder. Double-click on the Projections Lab Layers.zip compressed file. Take this folder called Projections Lab Layers and drag it from the compressed directory to the File Explorer window you have open to the GRASS Data directory. This step is very important. If you try to run these layers from within the compressed directory, they will not work. Close the Archive Manager software and close the 2 copies of File Explorer. Next, we will run GRASS. Open up a copy of the terminal window. I have it pinned here on the left, or you can find it by searching down below. Simply type GRASS, all lowercase. We need to tell GRASS where it will find our data. This is where GRASS is going to put all of our data, not just the data that we downloaded, but all of the new data that it has created. Click Browse, click your home directory, and scroll down to the GRASS data folder that we created. Select it and click Open. We need to create a new GRASS location to start using our sample data. Click on New. We will call this new project location Projection 1. No spaces. Click on Next. To choose a method for creating the new GRASS location, we are going to need to specify several attributes about this new location. We will read projection and datum terms from a georeference data file. Click on Next. Click on Browse. Go to your GRASS data folder, click on Projections Lab Layers, click on Texas Counties. The file that you will always be starting with in these circumstances is the one that ends in .shp. Select texascounties.shp and click Open. Click on Next. Click on Finish. Click OK. We told GRASS GIS to create a new location using the data attributes of the Texas Counties layer that we pointed it to. Now GRASS GIS is asking us if we want to import that layer called Texas Counties into that new location that we've set up. Click on Yes. Click OK. Click Start GRASS Session. Let's see what map projection and other important algorithms are being used for this GRASS GIS location. These parameters are set based upon the information from the Texas Counties layer. Click on Settings, Map Projections, Display Map Projection. The datum being used is North American Datum 1983. The ellipsoid being used is GRS 1980. And the projection being used is latitude-longitude. This means that the data is not stored in any projection. It is just stored in using latitude-longitude data on a spherical Earth. When we look at the data on our screen, it will be projected to us, but this is called projecting on the fly. That means that GRASS GIS is choosing a projection to be able to display the information flat on our screen. And we don't necessarily know what projection GRASS GIS is choosing for us. But the important thing is that the data itself is still stored in the form of data on a spherical Earth. That's what we get from this information here, LL, which means latitude, longitude, which means that no projection is being used in the format of the data. We already imported the Texas Counties layer into this GRASS GIS location when we first opened up GRASS GIS. All we need to do now to look at it is to display that layer in our table of contents. Click on the Layers tab. Nothing is being displayed right now. But if we go to File, Map Display, Add Vector. So the Texas Counties layer is already there within this GRASS location. It's just not being displayed. And that's why we're using the Map Display drop-down menu. And we're using Add Vector because this data is in the form of a vector. Click on Texas Counties. Click OK. And there you can see the counties of the state of Texas. If you are on a Windows machine, right-click. If you are on a Mac laptop, push down on the trackpad with 2 fingers. Click on Zoom to selected maps. And now we have the entire layer in the frame. Now we will look at another layer that's in another projection. You'll often hear me refer just to projections, but actually this new layer and any new layer that we open in GRASS can have a different projection, datum, and or ellipsoid. The 3 tend to go together. In order to look at another layer that's in another projection, and also perhaps a different datum and a different ellipsoid, we need to open up a new GRASS location. This GRASS location is set up for a certain ellipsoid, a certain assumption about the shape of the Earth. It's set up for a certain datum or coordinate system, which is a system of measuring distances on that assumption about the elliptical shape of the Earth. And this location is set up for a certain projection where that ellipsoid shape of the Earth with that particular coordinate system is projected onto our screen, or the data is projected and stored. In this case, we're not using a projection even. We're using what's called latitude and longitude, which is a pseudo-projection, the absence of a projection. But that is all specific to this particular layer. If we want to open up another layer that is based upon a different ellipsoid, a different model of the shape of the Earth, if we want to open up another layer that is based upon a different coordinate system or datum, meaning a different system of measuring distances on that Earth, where that ellipsoid is projected in some way, such as projected to make it flat, we need to look at that in another GRASS location that's set up to handle data that's in that different format. Click on Settings, then click on GRASS Working Environment, and then scroll down to Create New Location. We'll call this new location Projection 2. Click on Next. Click Read Projection and Datum Terms from a georeferenced data file. We're going to get the information about the projection and the associated ellipsoid and datum from the shape file that we're going to be importing. Click on Next. Click on Browse. Navigate into your home directory and then to your GRASS data folder and then to Projections Lab Layers. Double-click on Facilities. I don't remember what these facilities are, but this is some layer that I found many years ago. It's always going to be the file .shp, so highlight that file, facilities.shp, and click on Open. Click on Next. Click on Finish. Location created. Do you want to switch to the new location? Click Yes. Do you want to store the current settings to a workplace file? Click on No. Rest assured that the data that we've already imported is saved. This isn't about saving our current data. The data is saved automatically as we go along, so it's safe to click No. Click OK. Do you want to set the default region and extents? Click No. In this case, the new layer was not imported automatically for us, like it was with the first layer upon startup of GRASS GIS. In this case, we still need to import the layer. We've set up a new GRASS location that has the right specifications to be able to import this layer, and now we have to import this layer. Go to File, import vector data, because the format of this data that we're importing is vector data. Import of common vector formats. No reprojection is needed, so select the second choice from the list. If we also needed to reproject the data to get it to work in the location where we're importing it, then we would use this option. But since we don't need to project anything, since we set up this location to match this layer, we can simply import this layer without reprojection. Click on Browse. Click on your home directory and navigate to GRASS Data. Navigate to Projections Lab Layers. Click on Facilities. Click on Facilities.shp and click on Open. Click on Run. Now click on Close, because the command is finished. You'll notice that we still don't see the facilities layer. To be able to see the facilities layer, it is now imported into this GRASS location, but we still have to display it within this GRASS location so that it shows up in our table of contents, which is this Layers tab here. So we click on File, Map Display, because we've already imported the layer. Now we need to just display the layer. Click on Add Vector, because this is vector data. From the drop-down menu, select Facilities and click OK. Now, if you're on a Windows machine, right-click. If you're on a Mac laptop, push down with 2 fingers and click Zoom to selected maps. And here is our facilities layer. Previously, you saw Texas counties, and you saw that those were shapes. Here, this layer is comprised of points, where these points are marked by X's. So each one of these points corresponds to just a very precise location of some sort of facility. Whereas the other layer we were working at, which was also vector data, was vector data in the form of shapes, which took the shape of entire counties. So vector data, as you can see, can have different attributes. Vector data can be in the form of lines, shapes, or points. First, with the Texas counties data, you saw vector data in the form of shapes, which formed the shapes of counties. Here, you're seeing vector data in the form of points, marked by these X's, where the vector data is in the form of zero-dimensional points that are just exact geographic locations on the landscape of certain facilities, whatever these facilities may be. Let's look at the projection, datum, in other words, coordinate system, and the ellipsoid. Go to Settings, Map Projections, Display Map Projection. So the name of this projection is Albers equal area. The datum is again North American datum 1983. The ellipsoid, the model for the shape of the Earth, is based upon GRS 80. And the projection is Albers equal area. So these other items like the ellipsoid and the datum tend to go along with the projection. So GRASS will sometimes just refer overall to the projection, or you may hear me refer to just the projection, but understand that there's actually 3 different pieces of information. There's the projection, which is Albers equal area. There's the ellipsoid, which is the model for the shape of the Earth. And there's the datum, which is the coordinate system of how far different points are away from other points. And that's North American datum 1983. Another thing I'd like to show you here is that the units are in meters. So the distances among points in this projection are in meters. And this is actually a projection. The data is stored 2-dimensionally in the computer. It's not just displayed to us 2-dimensionally flat, it's stored 2-dimensionally. It's based upon a projected flat Earth. And so therefore we're able to calculate distances among points or among other types of vector objects in the units of meters. Here's what I would like you to do next. Navigate to your home directory and find your GRASS data folder. Navigate to the Projections Lab Layers folder. So far, we have looked at the Texas Counties layer and the Facilities layer. I would like you to follow the steps that I showed you so far for the Fire Hydrants layer, the Fire Station layer, the Land Use layer, and the Roads layer. So for each of those layers, what I want you to do is go back in this video to the 12 minutes and 44 seconds mark. 12 minutes and 44 seconds in. From there, go to all the way to 18 minutes and 50 seconds. So that's part of this video shows you the steps that I want you to repeat for each of those other layers. Go ahead and do that. One quick note about that, every time you make a new location, give it a unique, different name. So the next location that I'm making, I'm calling projection 3. The one after that, I'll call projection 4. And then projection 5, and so on. So don't try to reuse the names of any of your previous locations. All right, now after you've gone through on your own and done all of those other layers and imported them into GRASS GIS, we've got them all into the GRASS GIS database, but they're all in different GRASS locations based upon their different projections and their different ellipsoids and their different datums, as the case may be. What we want to do now is to get all these different layers into the same GRASS location. The way we do that is by reprojecting the other layers into the projection that we want. So the computer software can take the layer in its current projection and it can mathematically transform all of the data in that layer into the new desired projection, ellipsoid, and datum that we want. The way that you do this in GRASS is you go to the GRASS location that is in the projection, ellipsoid, and datum style that you want, and then you pull the other layers from where they are into a copy of them into the GRASS location where you want them. And in the process, GRASS will transform those layers to put them in the new projection and the new ellipsoid and the new datum. We're going to put all of our layers in the projection, ellipsoid, and datum of the Texas Counties layer. So we're going to use the Texas Counties layer's GRASS location, which is called projection 1. And we're going to pull in all of the other layers, transforming them as they're pulled in to the GRASS location of the Texas Counties layer. And then we'll have everything all together in the same GRASS location, and therefore it will all be in the same projection, ellipsoid, and datum. Go to Settings, go to GRASS Working Environment, go to Change Location and Map Set. We want projection 1. Click OK. Click OK. You may be wondering, where did the Texas counties go? They're there because we already imported them into this GRASS location. To see them, you just go to File, Map Display, Add Vector. So they're already there in this GRASS location. We just have to add them to the table of contents so that we can see them. Come down here to Texas Counties, click OK. And then we can zoom to layer. So it is there. And now, like I was telling you, we're going to pull in these other layers from their current GRASS locations, where each of those locations has its own projection, ellipsoid, and datum. We're going to pull them in to this GRASS location. And along the way, the software will transform those other layers so that they conform to the projection, ellipsoid, and datum of this location. And then we'll have them all together. This is a quick splice to ask you to consider subscribing to my channel by hitting the subscribe button. It does not cost anything. It is totally free. But if you like what I am doing and want to support my work, I encourage you to visit patreon.com/joshbanta and make a voluntary contribution. The link is in the show notes below. Your support helps me to deliver new content and keep this channel current and vibrant. Thank you. Go to File. Go to Import Vector Data. Go to, at the bottom, where it says Reproject Vector Map from Different GRASS Location. So we have to pull in the layers from projections 2, 3, 4, and 5. Each of these different GRASS locations is a different projection, as well as a different ellipsoid and datum, or different combinations of projections, ellipsoids, and datum. So we have to pull in the other layers that we've put into GRASS from these other GRASS locations. We have to pull them all into projection 1, which is where we are right now. So let's start with the layer that's in projection 2. So in that location, and then under optional, you can select permanent, or you can, I think, leave it blank. The layer that is in the GRASS location called projection 2 is the facilities layer. So now we're going to hit run. And it's done. And you can see it's done because you can see all the points there. We're going to hit close. You can see that it's done. Here we have our table of contents. We have the Texas counties layer, and here we have the facilities points layer. On a Windows machine, if you right click, or if you're on a Mac trackpad, if you push down with 2 fingers, go to zoom to selected maps, you can zoom in. So you can still see the outlines of the Texas counties in the background, but now you can see the point locations of those facilities listed here. And this is a value of a GIS. You can see the point locations of those facilities in the context of the counties in Texas where they occur, because we have now layered those 2 datas on top of one another. That's why they're called layers. Now, poof, you may have noticed on your screen on the table of contents, there's more layers listed there. And you may notice some more layers showing up in the map on the right. I want you to go through and add each of the other layers. I want you to pull them in from their current GRASS locations into this location so that they are transformed into the projection, ellipsoid, and datum of projection 1, which is the location that we're in right now, which is the location of the Texas counties layer. We're turning everything, all of the layers, into the projection, ellipsoid, and datum of the Texas counties layer. I want you to do the other layers on your own. The steps to follow to do that are from 26 minutes 4 seconds in this video until 27 minutes 23 seconds in this video. Follow those steps for each of the other layers so that you've added them all into your table of contents as you see here on my screen. To make sure that you've done everything as I've done it, to make sure that nothing has gone sideways for you, let's check that we're all together in the same GRASS location with the projection, ellipsoid, and datum that I have for my GRASS location. Let's make sure that yours is the same. To do that, go to Settings, Map Projections, Display Map Projection. So you should have all of your layers here in projection 1, which should be the Geodetic Reference System 1980 is the name of the projection, which has a North American datum 1983 datum and uses the ellipsoid model of the Earth of Geodetic Reference System 1980, and the projection is latitude, longitude, meaning that this data is not stored in any projection. It's stored on that ellipsoid, spheroid model of the Earth in 3 dimensions, even though it's displayed on our screen in 2 dimensions. The data in this case is stored in 2 dimensions, as indicated here by LL, which means latitude, longitude, which means that what we're seeing on our screen is a pseudo projection, that no projection is actually being used in terms of the way that the data is stored in the computer. You should have all of this same information showing up for you as I have here if you've done everything properly and nothing has gone sideways. And then you can click here on layers to go back to your table of contents again. To see if you've got the hang of it, we're going to take all of these layers and we're going to transform them into another GRASS location, which will have a different combination of projection, ellipsoid, and datum. You've already done this once. I'm going to have you do it again so that you can see if you've got the hang of it. Click on Settings from the drop-down menu at the top. Then select GRASS Working Environment. Then select Create New Location. Name the new location Projection 7 and then click on Next. Select the option Select EPSG code of the spatial reference system and click on Next. We're going to enter in the EPSG code of the datum, ellipsoid, and projection that we wish to use. The EPSG code will be 3574. GRASS GIS keeps a list. Click on Next. For Select Datum Transformation, stick with the defaults and click on OK. The EPSG code 3574 is a Lambert-Azimuth equal area projection. This is a projection that flattens the globe's surface to a disk, as represented here on your screen in 2 dimensions. The spherical Earth, represented here as a circle, is projected onto the disk, represented as the line at the bottom of your screen. The projection accurately represents area in all regions on the globe, but it does not accurately represent angles, so you will see that the shape of Texas is distorted. The distortion in a Lambert-Azimuth equal area projection depends upon the distance from a central point of the projection. Depending upon where the central point of the projection is, you will have the least distortion, with distortion increasing as you move away from that center. And there are different Lambert-Azimuth equal area projections that are based upon different origin or center points. We will be using a projection that is centered in the North Atlantic, so you will see distortions for the state of Texas. Click on Finish. When asked if you want to switch to the new location, click on Yes. Then click on OK. Do you want to set the default region and resolution? Click on No. Now we are going to reproject our different layers into this new projection. We're going to do that by going to File, Import Vector Data, Reproject Vector Map from different GRASS location. We're first going to reproject our layer from the Projection 1 location. This is the location of our Texas counties layer. For the map set, we're going to select Permanent. And for the name of the input vector map, from the drop-down menu, you will see that it is Texas counties. Click on Run. When completed, you may close the dialog window. We still do not see the Texas counties in our new projection because we have to zoom to that layer. So from the table of contents, highlight the Texas counties layer, right-click on a Windows-style mouse or push down on your Mac trackpad with 2 fingers, and scroll down to Zoom to selected maps. The layer was successfully reprojected into this strange new projection. We will repeat this process for all of our other layers. To repeat this process, go to File, Import Vector Data, Reproject Vector Map from different GRASS location, from the drop-down menu for the location containing the input vector map, now select Projection 2. The map set will be permanent. It's always the one called permanent. And the name of the input vector map will be whichever layer you have in your Projection 2. In my case, it's Facilities. I click on Run. When finished, I close the dialog window. And you can see that the Facilities layer was added to this map. We will repeat this process for all of the layers that we have. I will show you one more. File, Import Vector Data, Reproject Vector Map from different GRASS location. From the drop-down menu, this time select Projection 3. Choose Permanent for the map set, and whichever layer is in Projection 3 will be in the drop-down menu. Click on Run. When finished, click on Close. And you can see that the fire hydrants layer was added to the map. Repeat this for all 6 layers. Bring them all into this same new projection. Reproject them into this same new projection. To make sure that nothing has gone sideways, let's make sure that we are in the correct projection. Go to Settings, Computational Region, Show Current Region. And you can see that we are in the correct projection because you can see that it is the Lambert azimuth equal area projection centered on the North Atlantic as I described. So let's click back over here on the table of contents. Another important thing I want to show you is that the ordering of your layers in the table of contents affects how things are displayed. I want you to have things displayed as I have them here, where we can see all of the different layers on top of the Texas counties layer. In order for them to be on top of the Texas counties layer in the map, they have to be on top of the Texas counties layer in the table of contents. So here's those other layers superimposed on the Texas counties layer. Look what happens if I move the Texas counties layer to the top of the table of contents. Notice that we cannot see any of the other layers because the Texas counties layer is on top of them, and because all of the counties are shaded in gray, we can't see the layers underneath them. So if this is your situation, what you want to do is regular click on the Texas counties layer, hold that click, and drag the Texas counties layer just way, way, way down, and it'll snap down to the bottom. If you ever want to move something to the top, regular click on it, and hold the click and drag it way, way up to the top, and it will snap up to the top. So what you want to do is take that Texas counties layer and drag it all the way down so that it snaps to the bottom so that you can see all the other layers on top of it. Make sure that for each of these different GRASS locations, when you're finished importing everything, always make sure that you come down here to the Texas counties layer and zoom to selected maps so that the entire Texas counties layer is shown with all the other layers superimposed on top of it. Now I will show you how to import data that you collected yourself, hypothetically, into GRASS GIS. So far you've been working with GIS layers that are already in the shapefile format with that extension .shp. But what if you went out and you took GPS readings at a location? Say you found some fish species somewhere and you recorded with a GPS unit the exact latitude and longitude of where you were when you found that fish species. And let's say you wanted to import that point or a series of points like that into GRASS GIS. How would you do that? I'm going to show you how that import would work. I'm not going to show you the details of that file in this tutorial, although I will show you the details of that file in later tutorials, but this is a file that you can easily set up yourself. So here's how that import of your hypothetical GPS data would work. You'd get it in this file, you'd write it to this what's called a CSV file, and then this is how you would import that information from the CSV file into GRASS. The first thing we have to do is set up a new GRASS location. So we go to Settings, GRASS Working Environment, Create New Location. And sequentially, we'll just call this Projection 8. We're going to select the EPSG code of the spatial reference system. So click Next. And the one that we want is code number 4326 from this list. So we're going to go way down to 4326. So code 4326 is WGS 1984, or WGS 84 for short. This stands for World Geodetic System 1984. This is the datum that is used by GPS units. So if you take a GPS reading out in the field from a GPS unit, the datum that is being used is WGS 1984. Now, this WGS 1984 that we're using is going to be a pseudo projection, because when you collect a GPS reading from an actual location on the Earth, that GPS reading is stored in the form of latitude and longitude coordinates on a spheroid Earth, an ellipsoid shaped Earth, as opposed to a flattened two-dimensional Earth. So we're actually not going to have a projection associated with this. Click on Next. And this will be true whenever you take in your careers a reading with a GPS unit. By default, it's going to be using World Geodetic System 1984, this code 4326, which is a pseudo projection, meaning that it's based upon latitudes and longitudes, a coordinate system of a ellipsoid-shaped three-dimensional Earth. So after you click on Next, make sure you have this one selected here that says Used in Whole Region, and click OK. Click on Finish. Do you want to switch to the new location? Yes. We do not want to store the current settings to Workplace file. Click OK. Do you want to set the default region, extents, and resolution now? Click No. Now let's import that CSV file. Go to File, Import Vector Data, and we're going to choose ASCII points or GRASS ASCII format. Click Browse. Navigate to your GRASS data directory within your home folder. go to the Projections Lab Layers, and here's the file. Landscape Ecology Lab project.csv. Click Open. Name for output vector map, we'll call it LayLab PRJ. For the input format, the input is in the form of points. The GPS readings are individual points. The field separator, this is a CSV file, comma separated values file. So the field separator is commas. Under points, the number of header lines to skip at the top is 1. The column that has the x coordinates in it is the first column. The column that has the y coordinates in it is the second column. Click on Run. Now we can click on Close, because you can see it says Command Finished. We're going to zoom to the layer to make sure that it imported. So we're going to right-click on a Windows machine, or if you're on a Mac laptop, push down on the trackpad with 2 fingers, zoom to selected maps. And there it is. So here are these GPS points that were recorded. I don't know what they're GPS points of, but these were logged, and we're able to see them in the GIS database. To make sure that nothing has gone sideways for you, let's check the map projection and make sure it matches what I have on my screen. Settings, Map Projections, Display Map Projection. This is what you should have. World Geodetic System 1984. It's a pseudo projection that's actual latitudes and longitudes on a spheroid shaped Earth model. So the units are in units of degrees. So this is what you should have showing up on your screen right now if you've done everything properly to this point. Now we're going to add these GPS points that were collected in the field hypothetically by you, and that we've now imported into GRASS GIS. We're now going to add this layer of data points to the other layers that we've all combined together in that GRASS location called Projection 7. So we're going to transform these data points into the projection, datum, and ellipsoid of Projection 7, so that they're and have them there in that GRASS location. So to do that, we go to Settings, GRASS Working Environment, Change Location and Map Set. So we're going to go back to Projection 7. Click OK. Click OK. Again, you may be wondering, where did all the layers go? They're still there. They're just not in the table of contents. When you go back to a GRASS location from somewhere else, it clears the table of contents. So you have to display those layers again. They're there. They're in this GRASS directory, but we have to get them to display in the table of contents so that they will display on the map. So to do that, we go to File, Map Display, and here's a cool trick. Instead of selecting Add Vector, we'll select Add Multiple Rasters or Vectors. And then for the map type, switch it from raster to vector. And then notice that here are all of our layers and they all have check marks. Keep them all checked and click OK. But that hasn't solved the problem, because you'll notice that you still don't see them here. The next step is to have them checked, because layers will not show up on the map unless they're checked. But that still didn't fix the problem, because as you can see, the layers are still not showing up on the map, even though we have them in the table of contents and they're checked. That's because the map is showing us some part of the Earth that's different. It's not zoomed in on our part of the Earth where our layers occur. So the first thing is, I want you to highlight this Texas Counties layer, drag it to the bottom of the list like I showed you before, so that all the other layers will show up on top of it. And then I want you to look at the whole list of layers at the spatial extent of the Texas counties. So right-click if you're on a Windows machine, push with 2 fingers on the Mac trackpad if you're on a Mac, and select Zoom to Selected Maps. And there you have it. Here we have the Texas counties layer, and you can see the other layers showing up within the on top of the Texas counties layer. And now we're going to add those GPS points that you hypothetically collected in the field and are now bringing into this GIS database, into this GRASS location, so that you can look at these GPS points that you collected in the context of these other layers of information. So to do that, we go to File, Import Vector Data, Reproject Vector Map from a different GRASS location. And the GPS points that you hypothetically collected in the field and that we put into a CSV file and then imported into GRASS, those are in projection 8. I think you can leave this blank, but I'll just select permanent. Then for the name of the input vector to reproject, there it is. Click on Run. It's finished, so now we can close. And it might be difficult to see it on here, but sometimes if you check and uncheck the box, you can see the layer being displayed and disappearing on the map so that you can see where it is. We could also zoom to it. So we could do Zoom to Selected Maps. And then there are our GPS points. They're all around the city of Tyler. And here we can unclick it so that they go away. We can click it so that they show up again. So there they are. There's our GPS points. And this other mess here is different layers related to the city of Tyler. But there's our GPS points that we collected in the field. So let's go back out now and zoom to the layer of the Texas counties again. And there you have it. It's all there. And that concludes this lab on projections, transformations, and data import using GRASS GIS.